Welcome to video 4B, and we're still working with our transformations of geometric figures. We did the translation and the rotation in the previous video, and in this one we're going to do reflections. And it's layman's term. A reflection is really just a flip. And you will be told a line over which to flip it. So before we even begin trying to flip things, we've got to talk about what lines you're going to be flipping over. Very common is to just flip something over the x-axis, which I've just drawn in red. Sometimes you're asked to flip over the y-axis, which I've just delineated there in blue. But other times you're asked to reflect over other horizontal and vertical, or even sometimes slanted lines. And we need to remember what those look like. So before we even start doing some flipping, I'm going to graph the line y equals 9. When I say y equals 9, it means for every single point I plot, the y value is 9. The x value can be anything. If I were to make a chart for that, like from when you first started graphing lines, I'd say, you know what? You're locked in at 9. You can be anything, -10, 0. So what that means is we just go up to 9 on the y-axis, and my x can be anything, and I connect them. And so y equals a constant always gives us a horizontal line. So that if they ask you to flip or reflect over the line y equals 2, you'll draw a horizontal line through 2 on the y-axis. Similarly, if you're asked to flip over, say, the line x equals 9, what that means is, if I were to make a chart over here, it means x is always 9. No matter what, you have to be 9 to the right, 9 to the right, 9 to the right, 9 to the right, but y can be anything you want. So what we do is we go over here to 9 on the x-axis, and we draw a vertical line through all the points that have an x value of 9. So this vertical line is x equals 9. All right, so next up, once we can get our lines on there, we are going to talk about how we reflect over lines. So the first thing I'm just going to do is reflect a triangle over the y-axis. So let's go draw a triangle. Let's go put A right here. Let's put B over here. And I'm going to put C up here. And I'm going to connect that, so if you could as well. I've got triangle ABC, and remember we call that the pre-image. And we are going to, right over here, we are going to reflect, aka flip, triangle ABC. Sometimes it'll say across or over or about. It just depends on what verb they use there. Across the, and we're just going to do the y-axis for this one. So the easiest way to do a reflection is really just to walk to the reflection line and keep on walking in the same direction, because you're going to fold it over. What do I mean by that? When I fold this triangle over the y-axis, A is going to go to the other side. It takes 4 little grids to get to the y-axis, and so I'm going to have to walk 4 away because I'm going to fold over that. So I go like this. I go 1, 2, 3, 4 to get there. 1, 2, 3, 4. So I just say you walk to it and you walk away, and we're going to call that A prime. For B, I'm going to walk 2 to get there and keep on walking 2 more, because it's going to reflect or fold over to the opposite side. So B prime would be over here. C is on the reflection line. Kind of consider a fold in a sheet of paper. Any point on the fold, when you fold the paper, is going to stay put. And so anything on your reflection line will stay put. And there is my triangle reflected over the y-axis. And one other, we're going to reflect just a point, D. So let's go put point D on there. I'm going to put point D right here, just to keep it out of the way of all other stuff. And let's reflect it across the line y equals -4. Well, where is the line y equals -4? Again, that's a horizontal line through -4 on the y-axis. So 1, 2, 3, 4. Here's the line y equals -4. And I'm going to fold my paper over that line, and D is going to go from above it to below it. So to figure out how far below it I go, I walk to that reflection line. I say 1, 2, 3, 4, 5, 6 to get there. 1, 2, 3, 4, 5, 6. When I walk away, I call this D prime, and I would say that the image of D is D prime at -9, -10. So pretty straightforward there. Let's go see what we've got on the next page. Waiting for it to turn the page. It's being kind of slow now. It's probably going to turn twice here, but. So what we're going to do is two things. You're going to be asked to reflect over a line, and then you'll be asked to describe things that have already been reflected. So on this one, I'm to graph the image when I reflect it over the line y equals -2. Well, in order for me to reflect it over y equals -2, I have to draw the line y equals -2. Here's my y-axis. Y equaling -2 is any point on this horizontal line. So you'll make sure you graph that reflection line. Now what I'm going to do is fold my figure, this one right here, over that line. So you got to picture folding it, and it's going to go up above it, and I just need to count to get how far up above. Point Q. It'll take 2 to get there, so it'll fold 2 away, and I call it Q prime. Point whatever this is. I can't read it. 1, 2, 3 to get there, 1, 2, 3 to walk away. And this one right here is going to stay put because it's on the reflection line, and E is going to go one above it. So now when I connect those, I get that. And you can see that's exactly what I would get if I folded this entire figure over the line y equals -2. And I've just graphed the reflection. We're not going to do the next one. That's beyond the scope of what you would have to do in a regular Algebra 2 course. So we're going to move on to the next page where we're going to write a rule. These look like, how am I supposed to figure it out? It's really easy. Here's what you're going to do. You're going to grab one image point, and that would actually be a pre-image, and its image. So I'm grabbing F and F prime. I could grab K and K prime, V and V prime, J or J prime, doesn't matter. You just focus your eyes on one pair because there's lots of lines and lots of dots. And then you're going to split the distance between those 2 points, and that will give you the line that it's been reflected over. So I would say that the quadrilateral, we would call it, and it just says to write a rule. So the quadrilateral FVJK is reflected over this line. Well, what is that line? We got to go look at it. It's a horizontal line. And again, here's my x-axis running right here. And that's up at 2. So that's the line y equals 2. So when I write a rule, I would say that this is a reflection across, about, around, over the line y equals 2. And I'm done. And again, if it reflected from left to right, then it'd be x equals something. One more of those, and we shall quit. So on my next one, again, I'm just going to grab one pair, one pre-image, one image, split the distance between them, and I'm going to say what it reflected over. This would be a reflection across the x-axis, which is actually also known as the line y equals 0, because everywhere on the x-axis I don't go up or down. They all have a y coordinate of 0, so you could write that either way. All right, so last step is our dilations, and there's not a worksheet on the dilations. We're just going to go through this together. So in math, the word dilate means to expand or contract. Basically, it means to grow or to shrink in size. If we have a scale factor less than 1, and a scale factor is what you multiply by to get from one figure to another. If that number is less than 1, you can kind of think of percentages. Think of 1 as 100%, and if I multiply or take 90% of something or 80% of something, what it does is it shrinks it. And that happens geometrically with these as well. If a scale factor is greater than 1, like if I take 200% of something, it gets a lot bigger. And that's what happens geometrically when we're working with dilations. So it says graph the dilated image of triangle JKA using a scale factor of 2. What that means is I'm going to grab the coordinates of each of these points. J is sitting there at 2 to the right, 4 up. K is sitting at 1 to the right, 1 up. L is at 4 to the right, 0 up. When it says to dilate it with a scale factor of 2, what I'm going to do is multiply every single coordinate by 2. And this would become 4, 8, this would become 2, 2, and this would become 8, 0. I then replot those coordinates. So I go 4, 8, and that's my new J. I do 2, 2, and that's my new K. I do 8, 0, and that's my new L. And I've just dilated that by a scale factor of 2. Now what it says is this is a center of dilation. It's kind of like you're shining a light through this and you're blowing it up or magnifying it so that you're kind of seeing its larger shadow. If you pull it in towards the light, it shrinks. And it's not a light, it's the origin, but if you kind of think of it as a light, it kind of makes sense why that blows up. All right, so on number 5 it says I don't think we need to do number 5. Again, you just write down all of the coordinates, multiply each by 3, replot, and you're going to see this thing expand out and get 3 times as large. Let's move on to another one. All right, now I have a scale factor that's 1.5. It's kind of like 150%. I'm going to shine a light through this, and it's going to send each of those coordinates out 1.5 times where they are. So point X is at -4, 2. Point Y is at 6 to the right, 0 up. Point Z is at 2 to the left and 4 down. And I'm going to multiply each of these by 1.5. So each one, I'm going to do 1.5 of it. 1.5 of 4 is all of it, and then a half of it, or 6. So I'll be at -6. 1.5 of 2 is all of it, 2, and then half of it, 1, which will give me 3. 1.5 of 6 is all of it, 6, and then a half of it. So I'll be at 9. Notice I don't need a calculator. 1.5 of 0 is still 0. 1.5 of -2 would be the same as 1.5 of 2, just with the whatever, you get it. And then this would be at -6. We're good. And now I go replot all of those image points. X is going to move out and expand or blow out and go to this new location, and we call it X prime. Y is going to get pulled out 1.5, and by 1 it's all the way and then a half more. See what I mean? It all makes sense. And then -3, -6 is right about here. Z prime, I'm going to draw it, and it's like I just shone a light through there and magnified that by 1.5 times its original size. Now, when you're doing a scale factor that's less than 1, what it does is it sucks it in towards the origin, everything to 1/3 of its distance. So again, I would plot these points. This would be at 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 9. The new one would be at 1/3 of that. 1/3 of 3 is 1, 1/3 of 9 is 3. So my new M, or M prime, is going to get sucked in right here, 1/3 the distance of where it was from the origin. N is sitting at 6, 0. When I take 1/3 of that, I get 2, 0. So this is my new N. O is sitting at 3, -6. Taking 1/3 of each of those, I suck it in to 1, -2. I'm going to write these a little bit neater. And then this is O prime. And then my last one, P is at negative 3, 0. And when I do a third of that, I get negative 1, 0. And when I reconnect these, trying to draw it nice, I've just sucked that thing in to 1.5 times its distance from the origin, sorry, 1/3 time. Now, when you're going in reverse and you need to describe it, again, all you need to do is grab an original and write its coordinates down. Negative 6, comma, 1, 2, 3, 4, 5, 6. Negative 6, 6 got pulled in, so this is going to be what we call a contraction. It got pulled into negative 2, 2. Well, what causes this? And it would be, oh, divide by 3, which is true. So what this is this is a dilation with scale factor, and it's not 3 because that would have blown it up. It's a scale factor of 1/3 because everything got divided by 3. So that's it for this video. And you are now ready for worksheets 4.2 and 4.3. When those are completed, we will have a test.